Hello everybody, hello, my name is Lara, this is Theatre of Science, you are the Science Alliance, you are watching episode 6 of Astronomy. You don't need to have seen any of the other lessons to have seen this one, although we will be harking back a bit to last lesson. Because one of the questions I've asked you is, where does the solar system end? So we're learning about comets today. That's such like patronising children's TV presenter from the 60s. Ooh, let's learn about comets. So when you say solar system, this is usually what you think of, isn't it? The sun and 8 planets going around the sun. And last week we looked at how the sun and all the planets, you can sort of think of them as being on like the same disk. They're all on the same plane, yeah? So if you imagine a plate with the sun in the centre of the plate, you could just plop all the planets around it and they'd all be spinning around it and they'd all be kind of on the same plane, you know, at the same angle, because the planets formed from a disk of stuff that was spinning around the sun, all right? So there's a couple of things we didn't talk about last lesson. We've got the sun, we've got the rocky planets, Mercury, Venus, Earth and Mars. In between, just after Mars, there's actually some rocks that just never managed to clump together to form planets. This is the asteroid belt, okay? It's called a belt because it's flat, going around the sun just in the same way that the planets are. It's made of rocky things we sort of looked at a while last week. So that's the asteroid belt. We're not going to talk about it. This lesson is not on asteroids, all right? Forget about them. Might touch on them next week. Then you've got the gas giants, Jupiter, Saturn, Uranus and Neptune. And then after that, there's more stuff. So if you thought that the solar system ended after Neptune, no. These bits of stuff are more icy. Okay, again, we looked at one last week. They're massive chunks of ice, some of them kilometres wide. It's not just water that's frozen. It's all kind of things like ammonia that's making up the clouds of Jupiter. Some of that is frozen. You might have heard of methane, that's frozen. Astronomers call them dirty snowballs because it's just ice of various kinds and dust and rubble all clumped together. But again, it can't form a planet because Neptune, the gravity of Neptune, is sort of stirring it up. So it's just doomed to orbit the sun like the planets do, but in sort of, you know, reasonably uninteresting icy chunks. This is where dwarf planets are as well. This is where Pluto is. If you are saying that maybe the solar system ends at Pluto, well, this bit altogether is called the Kuiper belt. Kuiper. And yes, like I say, belt, because it's just like a belt really around the sun. Oh, I'm doing that. I don't have to write backwards because it's YouTube. Yes, YouTube. When I do these on Facebook, I have to write backwards. Kuiper belt. And the Kuiper belt is where comets come from, because sometimes one of these massive icy chunks gets knocked out of its orbit, and instead of going around the sun in a sort of beautiful kind of circle-y shape, it starts going around like this, like a sort of big oval, like elliptic shape. So it goes from being very far away from the sun all the time to being quite close to the sun and then back again, all right? So that's what comets are. Icy chunks that haven't formed planets because Neptune just messing them up, that occasionally get knocked out of orbit and go around the sun. What does a comet look like? Possibly the weirdest question sheet I've ever made you to get you to try and think about that. Have a go at this. I'm a bit embarrassed about this. What are comets, right? Well, imagine that a snowman is riding on a skateboard. That's a totally normal situation. Yeah, it is only a snowman's head because it didn't work otherwise. Just go with it. As the snowman's head rolls along, it melts and bit falls off. Quick sketch, please. Can you draw the mouth, the hat, the eyes, the nose, and the melted snow where you think they might land? I've said that the head is the last thing to fall off the skateboard, so it has been drawn for you. Okay? Do you get it? Perfectly reasonable way to learn about comets. If you've finished, can you pretend that you're floating in the sky and draw the melted snowman from above? All right, like a bird's eye view. Like imagine you're piloting the news helicopter because a massive snowman's head has been seen rolling through the streets of London. They've called you in. You look down. What do you see? And if this all just seems like too much nonsense, you could consider, why is a comet like this snowman? And how is a comet different from this decapitated snowman? I'm going to give you, like 10 seconds because this is ridiculous. 5, 4, go on, snowman from above and snowman from the side. 3, 2, 1. Okay, this is what I did. Well, obviously the hat's going to fall off, isn't it? The eyes, all the little bits are going to fall off, but not necessarily at the same time. So you'd end up with a little trail, a tail, if you will, of kind of snowman debris. And then I said maybe you could draw in some melted snow. Where would the melted snow mainly be? What do you reckon? I reckon it'd be around the head, right? That's where the head is, so the snow would melt and kind of surround the head. So the bird's eye view version that I did was something like this. Kind of like a fried egg with a little tail of stuff behind it, right? I think that's not a terrible model for what a comet is. Okay, come over here, right. So we've got this icy chunk in the sky, like this, and it's getting closer and closer to the sun, all right? So it is heating up. Now, where the melted snowman is immediately not a very good model is that usually we see ice turning into liquid, don't we? It goes from a solid to being a liquid. The comet is solid ice, but it gets so hot so fast that the solid ice goes straight into gas. It's called sublimation, if you want the posh sciencey word, and you end up with this fuzzy little cloud around the chunk of ice, and that is how the comet gets its name. It's I think it's Latin for hair. It's called the comma, the little cloud of gas, just the snow, the ice that has melted, forming this gas around the snowball. That's called the comet. So comet, right? It means hair, I think, in Latin. Because comets, when people looked up at them in the sky thousands of years ago, they looked a bit blurry, and that's why it's a little cloud of gas. So this bit in the middle, the dirty snowball, is called the nucleus, the centre. And this bit, you might have seen, the tail of the comet, is called the tail. Thanks, astronomers. A biologist would have called it something else, wouldn't they? The tabulata. No, it's just the tail. And the tail is kind of like the trail of snowman stuff, like the hat and the eyes and things. What's happening is the sun is giving off what we call the solar wind, all right? Just kind of particles, basically, just blasting the comet with particles. And that is pushing some of the gas and some of the bits, well, yeah, mainly gas from the melting comet out behind it, okay? So you can tell, if you look at a photo of a comet, you can tell where the sun was in the sky when the picture was taken, because the sun is always right in front of the comet, yeah? You blasting the tail out behind it. Is that okay? So that's what a comet looks like. Sorry, if you're making notes, there's one more note to make. This is called a short period comet. It's called a short period comet because it doesn't take that long to go around the sun. It only takes 200 years or less. 200 years or less to go around the sun. Which is why it's a short period comet. Does that make sense? Yeah, because it's only come from the Kuiper belt, yeah? So we've got Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then this ring of icy chunks. It takes about 200 years for an icy chunk to get knocked out of its orbit around the sun and then back again, and then it'll just keep doing that. So 200 years, short-tailed comet. There are comets that take a lot longer to go around the sun, which we will talk about in a sec. I should just show you a picture of an actual comet, shouldn't I, in case this isn't doing it for you. Here we go. So this image is from NASA. Isn't that stunning? Look at that. But actually, even more exciting than the image were the words that I read on NASA's website that said, this is Ison, so a comet. It's its very first trip around the sun. It is still made of pristine, that means kind of, what does that mean? Pristine, like untouched, completely unspoiled matter from the earliest days of the solar system's formation. Its top layers never having been lost. How amazing is that? You're looking at a comet in the sky and it's just a bit of stuff that formed billions of years ago when the solar system was forming. Amazing. But there's something more amazing than that, actually. I'm so excited. If you didn't know where the solar system ended, I'm so excited that I get to tell you this. Because to be honest, I didn't really know either. So, actually, I don't even, yeah, right. Get a sock. I said to bring a sock. Have you got one? Have I got one? Here's one. So, the Kuiper Belt is just icy chunks that can't form a planet because Neptune is kind of stirring them up a bit, all right? But let's talk about Jupiter, the biggest planet. It's got a lot of mass, it's got a lot of gravity. So when stuff comes near to Jupiter, it could just swallow it. That happens quite a lot, right? It just becomes more massive because it grabs it. But that isn't always what happens when stuff gets near Jupiter. So get a sock and just start swinging it around for me, okay? Imagine that you're Jupiter, you've got a lot of mass, stuff's come towards you, let go of the sock at any time, try and hit someone. When we did this on Facebook yesterday, it landed on a kitten in someone's house. I don't have any kittens, so that wasn't as interesting. But that's what Jupiter does to some icy chunks, and it's what it did do. Like years and years and years ago, it just slingshotted them out. How good is that? So what this means is that these bits of icy chunk just got flung everywhere by Jupiter. So they're not necessarily in this beautiful neat disk that we've been talking about that everything else in the solar system seems to fit. Here, I'll show you. I did pictures. So here's the solar system that everyone's comfortable with. Sun, planets, remember asteroid belt made of rocks. Not going to talk about that. Nothing in this lesson is to do with asteroids. We've learned, if you didn't know already, that there's a ring of icy chunks around that called the Kuiper Belt. Well, because of Jupiter throwing things elsewhere, there's also, if we zoom out a lot, this massive cloud around the entire solar system called the Oort cloud. I've tried to show that it's not flat, it's just all, it's like a ball. And this Oort cloud is so far away. I'm going to attempt to tell you, using some numbers that NASA gave me, just how far away this thing is, okay? So it takes light 8 minutes to get from Sun to Earth, all right? It's travelling at the speed of light. It's going faster than anything can go in the whole universe, and it still takes 8 minutes to get to the Sun from Earth. To get to Neptune, it takes light 4.5 hours, going at the speed of light. That's a long way, okay? If you went for another 12, if you went for, wait, wow, I wish I hadn't started this. Oh yeah, 7.5 hours. 7.5 hours it takes to go from the Sun to the Kuiper Belt, okay? Where the short period comets are coming from. 7.5 hours from the Sun to the Kuiper Belt for light to go. To get to the Oort cloud, it would take about 28 days. Speed of light, 28 days. So this is kind of where the end of the solar system is, the Oort cloud, just miles and miles and miles away. We've never been because it's so far away. We only know that it exists because we've predicted it. One of the ways is because we've seen comets going past at like weird angles that wouldn't have come from the Kuiper Belt. So we've just had to assume that the Kuiper Belt exists, that the Oort cloud exists. Pretty good, eh? Right. There's something that we haven't talked about. Just want to briefly mention it. I'm going to show you some pictures of real comets. See if you can spot something odd. Can you spot something that I've not taught you thus far in this lesson? Here are 4 comets. Look at them carefully. Can you see anything that I haven't mentioned? Anything? I mean, actually, there's absolutely loads of stuff that we haven't mentioned. I'll give you a clue. It's not to do with colour. It's not about the colour. That one is particularly good, I think. What haven't I mentioned that you might notice about these comets? This photo, by the way, taken in 1892. 1892, how good is that? All right, there's no comets, so we'll be here forever. I'll just assume that you have noticed there's 2 tails, aren't there? And that is actually true. Comets do have 2 tails. I've just been keeping it simple. This tail that is blasted out by the sun is called the gas tail. If you're making notes, you might want to make more notes. There is another tail called the dust tail, which is sort of a bit less powered, kind of going off down at an angle. I've accidentally drawn those numbers on it, but that's your dust tail, okay? Just write it here. So we're not going to really talk about the dust tail, except it's full of dust and rocks. And we do need to talk about those because we need to talk about meteorites and meteoroids and meteors and how to tell the difference and do an activity. Okay, I'm really happy with this activity. Okay, get a baking tray and get a piece of paper long ways and sellotape the piece of paper to the baking tray. So all I want you to do, I just want you to do that, but you know, don't be hot. For goodness sake, Lara, they've understood you. Get sellotaping your paper to your baking tray. So comets go around the sun fairly frequently, like sort of every few years, and some of them are quite regular. Well, some of them come around like regularly enough that we can predict them, and the Earth sometimes rolls into the tail of one of these comets. So especially this is where the dust tail comes in, that's full of dust and chunks. We just go through this cloud of dust and chunks. So the cloud of dust, these little bits of rock basically that are in space, when they're just hanging around in space, they're called meteoroids. But when they hit Earth's atmosphere, they get called meteors, and this is a difference that we have to remember. So when you've sellotaped your paper to your baking tray, we need to do some labelling, all right? So we're going to say that the very top of your paper is space, and the very bottom of your paper is Earth. Let's draw a line to show Earth. There we go. So just draw a line on the bottom of your paper to show where Earth is. So we've got these meteoroids that are in space, just rocks. It's a weird word. Meteoroid just means rocks floating in space, like on the tail of a comet, say. But when they pass through Earth's atmosphere, something gorgeous and amazing happens. Earth's atmosphere, just air particles, that bash into the rock. The rock comes really fast through the air, the atmosphere, and it burns up. It gets really hot and warm, and eventually it burns up. And that's what we call a shooting star. If you see a shooting star in the sky, and they're fairly common, like you see about 7 an hour if the sky is very dark, it's actually just a little bit of rock, which might have come from a comet, getting burned up in Earth's atmosphere. So we need an atmosphere. What we're going to do is get a big streak of paint and put it in the sky to be our comet with our meteoroids in it. And we're going to see if any of those meteoroids get to Earth. But in the way is Earth's atmosphere. So you need to stick some toilet roll just above Earth to catch the meteoroids, okay? So I'm going to do that too. So there's meteoroids that are up in space. When they're burning up in Earth's atmosphere and being like shooting stars, they are meteors. That's a proper word for a shooting star. A meteor is a meteoroid that's got burned up in Earth's atmosphere. Are you following so far? So what's it called when it hits Earth? If it hits Earth. Not a lot of them do hit Earth because they get burnt up. But some of them do. When they hit Earth, they are called meteorites. Have you got a good way of remembering all those different words? Because I think I've finally got a way to remember the difference between a meteor and a meteorite. Here we go. This is what you're aiming for. Space at the top, Earth's atmosphere, this bit of toilet roll, and then Earth right on the bottom, okay? I guess I'll label the atmosphere. There we go. Okay, so when you're ready, get some, it's got to be very watery paint. Splosh a painty comet in the sky, and we'll see meteoroids, just rocks in space, rolling down, hitting Earth's atmosphere and hopefully streaking and looking all beautiful. And they will be meteors, like a meteor shower is when Earth goes through the tail of a comet. We see loads of meteors. That's a meteor shower. And if it gets to Earth, it will be called a meteorite. The meteorite is like the rock that you find. Okay, here we go. Let's do it. Yeah. Now, I haven't been very successful at getting meteorites. So hopefully, this being the third and last lesson, this will work now. Okay, so there's my comet with the meteoroids staying very much where they are. Give it a bit more of a tail. Oh, there we go. So I got a meteor, okay? If you were standing on Earth and looking up, you'd see a beautiful streak in the sky as this meteoroid burned up. It's quite a good model, right? Because the tissue paper is kind of slowing down the paint and kind of dispersing it so it doesn't hit Earth. That's pretty good. But I want to get a meteorite. I want my meteor to get to the ground. It's going to take some time. Come on. I'm going to have to cheat. And just stab. So meteoroid is quite a strange word that we don't use very much because we don't really talk about rocks just hanging in space, do we? We talk about meteors a lot more. Like there's a meteor shower coming up really soon, actually, the Perseid meteor shower, which is when we go through a tail of the comet that we sort of know is coming every year. So we see meteor showers quite a lot. How I'm going to remember the difference between a meteor and a meteorite is that I think it's pretty cool if a rock hits Earth, like not if it lands on you, but generally speaking, to find a meteorite, a bit of rock from space that had made it to Earth, that would be cool. So if I found that, I'd say, meteorite, which is like kind of embarrassing and naff, but every time I talk about meteors and meteorites now, in my head, I'm going to be saying, meteorite, yeah, finding some rock on the ground, that would be good. So that's the one that's a meteorite. Where's my meteorite? Oh, come on, that's got to do it. So these are all meteors. I'm just waiting for it to hit the... Oh, so the... Come on. Yes, it's going to cross the finish line. Can't believe this is the last time I get to do this activity. I'm just going to be doing it for fun on my own. My arm muscles can't take it anymore. All right, I'm going to say that's a meteor. Right, and I'm going to label them. Whew. So this bit in the sky, before it hits the toilet roll atmosphere, that is a meteoroid. I'm having trouble spelling these. E, and then there's an O, and then R, and then oid. Meteoroid. And the stuff that's, the really gross stuff that's in the toilet roll atmosphere, those are meteors. Meteors. And at the bottom here, I've got a meteorite. Meteorite. Exclamation mark, because they're my favourite ones. Cool. Well, I hope that has helped a bit. While you're finishing that off, I said that the comets that came from the Kuiper belt, the one that's reasonably nearby, only takes like 7.5 hours to get there. Those are called the short phase comets. So the comets that come from the Oort cloud, which is ages away, those are called long phase comets. Long period comets. And we say that they just take over 200 years, but they could take a lot more than 200 years. Let's change this, not short period, it's long period. Yeah, long period comets take at least 200 years, but sometimes a lot more. Sometimes it's like millions of years to get from the Oort cloud to the sun. Like a long phase comet coming from the Oort cloud past Earth tomorrow would probably not, like last time it came past, humans wouldn't have even been on Earth, like wouldn't have been a species. Just awesome. So yeah, what have we learned before we go to the questions? There are short period comets that come from just beyond Neptune, and there are where the Kuiper belt is, and there are long period comets that come from the Oort cloud, which is a cloud of stuff encircling our solar system, and they've got gas tails which are blasted out by the sun. Yeah, all right, that's pretty good. Questions that people have been asking me on Facebook. Have we ever landed on a comet? Yeah, we have, yeah. It's the European Space Agency. It actually bounced at first, and they kind of predicted that, because if you've ever made a really hard snowball, don't do it, it's evil. But you know, if you get a snowball and you rub it, you kind of melt the outside and then it freezes again into really hard ice. The comet was a lot harder, I think, than a lot of them were expecting. Probably for this reason, that it melted and hardened into really thick ice. It doesn't happen with all comets, but it happened with the one that they were trying to land on. So this lander bounced a bit, but then it did land. And yeah, spacecraft have orbited comets, incredible feat, and collected material from them. So they've collected material from a comet, they've brought it down to Earth and found that it contains what we call organic compounds. So you need certain ingredients for life to begin on a planet. Like they found amino acids on this comet, which is one of the things you need for life to begin. So it's a real theory, like it's not a laughable theory, that instead of life kind of coming into being, all the ingredients being on Earth and kind of appearing on Earth, it could be the comet brought them. Maybe. Maybe we're only here because material was carried through deepest, darkest space on a comet, which hit a dead planet and brought it to life. I don't know. Astronomy though, right? Okay, I think those are the cool facts that I needed to tell you. Let's do some GCSE questions, shall we? Some multiple choices. Here we are. Illustration by vecteasy.com. Thanks, Vecteasy. Right, here's your GCSE questions. The comet Swift-Tuttle, that's its real name, gets close to the sun every 135 years. But what is Swift-Tuttle then? Is it a short-phase comet, a short-period comet, a long-period comet, or a long-phase comet? I accidentally said one of those earlier, so I might have well confused you. Well done if you get that right. The photo shows Halley's Comet in 1910. Which letter might mark the position of the sun? Distances are not to scale. So we've got a comet here speeding from the bottom left of the picture to the top right of the picture. Would the sun be in the top right, where it's going, in the bottom right, which is, sorry, the first one is A, bottom right is D. Would it be bottom left, which is B, or would it be top left, which is C? Question 3, in 1992, a rock fell from space and hit a car in New York City. True story. But what was the rock? If a rock falls from space and hits a car, what do we call it? Is a meteoroid, a comet, a meteorite, or a meteor? And your summary questions. Where do comets come from? Is it the Oort cloud or the Kuiper belt, or is it both? And the last question, which I found quite hard to answer actually when I gave it a go. Would you be excited to see a comet? That's the easy bit. But can you explain why or why not, using as many ideas from this lesson as you can? You can add your own ideas as well, but based on what you've learned today, why would, if you think you'd be more excited to see a comet now, less excited, if excited, why would you be excited? Because I'd definitely be more excited to see a comet now. I've learned about them. But explaining why is actually quite hard. They're mainly multiple choice, aren't they? So I'll give you, I don't know, what do you think? Another 15 seconds and then we'll go through it. Check through your answers. If this was a GCSE paper, you'd be checking your answers, making sure. Okay. Here we go. So the comet Swift-Tuttle orbits the sun every 135 years. Swift-Tuttle is a short period comet. A short period comet. It takes less than 200 years. If it was more than 200 years, it would be a long period comet. In this photo, well, the sun is blasting the gas behind the comet. So it is A. In the same way that if you looked at that snowman debris, you'd know which direction the snowman had been rolling in. Well done if you got that. A rock landing from space on Earth is called a meteoroid, because it's very cool. No one was hurt, and actually the car is now in some sort of meteorite museum, so everyone did well out of it. Where do comets come from? Well, you could have, it's right if you said any of these, because it is both. They come from the Kuiper belt, that's where the short periods come from, and they also come from the Oort cloud miles away, which is where the long period comes from. Would you be excited to see a comet? Explain why or why not. I will be deeply more excited to see a comet now, because I'll have questions about it. Because we don't know necessarily when they're going to appear. Like, they're fairly hard to predict, but they come fairly often, like between sort of every 25 and 40 years. Generally speaking, has been when you've been able to see a comet in the sky. And obviously they don't all follow any kind of pattern. I'd be excited now because I'd want to know if it was a long phase one or a short phase one. And if it was a long phase one, I'd be really excited that I was seeing something from the Oort cloud, which has come so far. And if it was a short phase one, I'd be excited to be seeing like an icy chunk that was next to Neptune. I just don't know, very exciting. Right, I'm going to turn you around. I hope you had a slightly more eloquent answer to the last one. A lot of people saying because they're beautiful. Yeah. I'd want to be able to know if I could see the two tails. I'd be getting my telescope out. Anyway, that's the end of that. But yes, there is a comet. There's a meteor shower. Meteors, bits of rock burning up in our atmosphere. Meteor shower very soon. Look out for the Perseid meteor shower. It actually starts in a few days and it peaks in sort of early August. You have to look up the date. But the first GCSE question, the comet Swift-Tuttle, gets close to the sun every 135 years. It's the comet Swift-Tuttle that causes the Perseid meteor shower. When Earth moves into its tail, then we see all these little bits of rock burning up in the sky. Ah! Okay, if you are enjoying these lessons and you would like to support me, then you totally can. You can send me money and I will receive it gratefully. £5 or £6 a month from everyone who's watching is totally enough for me to be able to actually do this as a job. So if you sign up today, you go to the About bit of YouTube. Where is it? Go to the About section. It'll link you to this website called Coffee. And if you go to Coffee, you can pay me £5 or £6 a month for 4 home ed shows a month, and like a show with a load of story time. I'm breaking next week for the summer holidays. We've got one more lesson left before the summer holidays. I'll send you a bit of Science magazine every couple of months. It's always got a craft in the back. This one's on rainforests, so you can mount your own beetles. It's got Choose Your Own Adventure that I've written. Husband has illustrated beautifully a comic about an insect expert you should know all about. I'm super proud of Theatre of Science magazine. Thank you to everyone who's receiving it. I'll also send you some rainbow glasses because they're just super cool and everyone needs them in their lives. And some information about how rainbow how glasses work. I'll be very excited. And I'll send you nice things. Right, I'm just going over to Facebook now to see if anyone has written any questions or left me any comments. If you're not on Facebook, then sorry, I need to work that out. But if you are on Facebook, then you can go to my Facebook group and there's free printouts for these lessons. It's not essential, it's basically just what's on the slide, but might make it a bit easier to answer some of the questions. And also you can say hello if you like to. Oh, hello, great, there's comments. Who's here? Oh, Rue's watching. Oh, brilliant. Oh, thinking that we could do a Science of Dreams lesson. Science of Dreams. Rue, the Science of Dreams. I don't know anything. Yeah. I don't know anything about it. Every time I look it up, the internet just says, no one knows how we dream. Yeah, there must be more to it than that, eh? Okay, I'll have a look. Oh, hello, Robin and Hissy. Oh, you like my Jurassic Park mug? Yeah, it's good, isn't it? Yeah. Yeah. Do you like my t-shirt as well? I don't think anyone's been able to see it this whole lesson, but it is appropriate. Is the Oort cloud mentioned in here? Ah, fabulous. Yes, it is. It is very interesting, isn't it? Yeah, I must admit I knew very little about it. Oh, Jack and Suze. And Mary. Suze needs to know whether I am left-handed or whether it's some weird YouTube backwards mirror imaging thing. Oh yeah, that must be really confusing. Yeah, I am actually left-handed. Yeah, good spot. Yeah, that's true. I'm writing backwards with my left hand, but I'm wearing a t-shirt that's forwards. Yes. Yeah, don't think about it too much. The tail splits in two. Oh, hello, Suki and Arza and Eunice. Hello. Yeah, the tail splits in two. It's a quite complicated physics, which is why I sort of avoided it. The solar wind that I talked about, blasting the comet, is actually charged. It's charged particles, you know, like positive and negative, charged particles. And it's carrying magnetic field lines from the sun. And the gas in the gas that's coming off is also charged. So that's why it's getting it's following the magnetic field lines. But the dust is also being sort of pushed by like the light from the sun. It is under pressure, but it's a bit heavier, and it's not being carried as. But this is why I didn't try to explain it. You see what happens, Jack and Mary. Do you see what happens? But yes, there are two tails. Yeah. Right, that's it. Thank you so much for coming. So the show next week is the hotly awaited Sloths versus Pigeons. What does it even mean? I don't know. Totally unrelated, beautiful crafting activity to go along with it because it's the last one before the summer holidays. So if you want to come to that, yay! That's at the usual time on Wednesday at 9:30 on YouTube, but also on Facebook. Just go on Facebook and it's all there. Right, you lot. I'll see you later. Thanks so much for coming. Bye.